Hi guys, in thermochemistry video number 1, we discussed what is thermochemistry and what is the difference between system and surroundings. In this video, we will be discussing about the applications of system and surroundings. To understand the application of system and surroundings, we first need to understand this formula, that's Q is equal to mc delta T. In the formula Q is equal to mc delta T, Q stands for energy lost or gained, unit of energy is joules, can be represented as J. M is the mass of substance undergoing reaction. C is the specific heat of substance, again undergoing reaction, and delta T is the temperature change. We will be able to understand it better once we are doing the question. In this formula, we first need to understand what is the specific heat capacity. So in order to explain you specific heat capacity, we just need to know the simple definition of specific heat capacity, that is the amount of energy absorbed by 1 gram of substance to raise its temperature by 1 degree Celsius. What does this mean? This means that how much amount of energy you need to provide a substance. For example, let's take water. How much amount of energy do you need to supply water with if you want to raise the temperature of 1 gram of water by 1 degree Celsius? So if we have 1 gram of water, and we need to raise its temperature from 37 degrees Celsius to 38 degrees Celsius. That's a 1 degree Celsius change. Then how much amount of energy is required by this 1 gram of water? And that is a specific heat capacity of water. That is not going to change for water forever. And the specific heat capacity of liquid water is 4.19 joules per gram degrees Celsius. So from here we know that 1 gram of water, if it wants to change its temperature from 37 to 38 degrees Celsius, would require 4.19 joules of energy. Now since we all understand what is specific heat capacity, our units for mass will go according to the specific heat capacity. So our mass needs to be in grams if we want to use the specific heat capacity unit in joules per gram degree Celsius. Temperature change has to be in degrees Celsius. Now let's read the question in order to solve this question. The question wants us to find out how much heat must be added to 36.2 grams sample of iron. Here we don't have water, here our substance is iron. So first let's write on what is given. We are given mass of iron is 36.2 grams. Next we are given the temperature change required for iron is 250 degrees Celsius. So the temperature change is delta T. Delta T is 250 degrees Celsius. Specific heat capacity of iron is given to you. You don't have to memorize the values of specific heat capacity. They will be given to you except for water. For water, you have to memorize. It's 0.449 joules per gram degree Celsius. They want us to find out how much heat must be added. So that means heat is a form of energy. We have to find out Q. Let's go to calculation part. Because we know the formula is Q is equal to mc delta T. All we have to do is just substitute what is given to us. M is 36.2 times C is the specific heat capacity, and that is 0.449 times delta T is the change in temperature, and we have been given the change in temperature to be 250 degrees Celsius. When we put this all on the calculator and multiply this, we get as 4063.45 joules. And that's our final answer.